Okay, so in this section, we're going to go ahead and talk about the chain rule. Now, the chain rule is used when taking the derivative of composite functions. In college algebra, we talked about composite functions, where we have the form of f of g of x. That means we have one function placed inside of another function. So in this case, if we have f of x is 2x plus 5 quantity squared, and this should be g of x, I apologize, and g of x is equal to the square root of x squared plus 4. So what we're going to do when we have composite functions is we're going to take each function, and wherever there's an x in the other function, so in this case g of x, anywhere where there's an x here, in this case here, we're going to stick this square root of x squared plus 4 inside of it. And so composite functions are just functions within a functions, and that's how we're going to go ahead and use our chain rule. So we're going to go ahead right now and just practice writing composite functions. I'm given two functions. So here we have f of x is equal to the square root of x plus 2. G of x is equal to 8x squared minus 6. And we're going to find f of g of x as well as a reverse g of f of x. So for f of g of x, we're going to take g of x, which is our 8x squared minus 6, and we're going to place it inside the f of x wherever there's an x. So the square root of x plus 2, that x takes on our g of x, 8x squared minus 6, and then we add the 2 to it. And all of that is underneath our square root. And when we go ahead and simplify this, we have the square root of 8x squared minus 4. We can't do anything else with that. Right, so now if we go ahead and do g of f of x, it's going to get a little bit more complicated. So our g, we're going to take our x squared plus 2 from our f of x and place it into our g of x. All right, so our 8 stays. Our square root of x plus 2 gets squared because our x term is squared in the g of x, and then minus 6. All right. So then we have to go ahead. Now, when we square a square root, the square root just goes away. That makes it pretty easy. And so we have to go ahead and take our 8 and multiply it by our x plus 2 through the distributive property, and then subtract 6. So we end up with 8x plus 16 from the distribution minus 6, and it simplifies to 8x plus 10. Right? And then also now there's another example where we have f of x is equal to square root of x plus 1. G of x is negative 1 over x. And again, if we have g of x and plug it into f of x, that means that this x gets replaced by the negative 1 over x plus 1. Now here, in order to simplify it, we have to go ahead and find a common denominator and go ahead and place that in there. Now, we also reverse the order. So plus 1 becomes x over x, but we reverse the order so that we don't have the negative in front. In reality, it doesn't matter, but it just makes it a little bit cleaner. And if we go ahead and plug f of x into g, all that does is take that square root and stick in the denominator of g of x, and we have negative 1 over the square root of x plus 1. At this point, there's no need to go ahead and rationalize the denominator. We have found the composite function that we were asked to go ahead and find. All right. And now we're going to go ahead and work backwards. So we're going to be given functions, and we're going to find it as a composition of two different functions. And mind you, there's several ways to do this. There's not only one correct answer to this. But here, if I have y is equal to 5 minus x squared quantity to the 3/5 power, generally I want to go ahead and identify these as f of x and as g of x. All right. And most obviously, it would be easiest to go ahead and consider that whole inside function to go ahead and be x and take it to the fractional power 3 over 5. And that could be one way. And then take our g of x and go ahead and place just as the inside, which is 5 minus x squared. And a lot of the times, this is what we want to do. We want to go ahead and do our outside function as one separate thing and have it as one variable. And then the inside becomes its own function. Whether you call them one f of x, one g of x, it doesn't matter. They are reversible, but just make sure that if you're identifying f of g of x, remember we want the inside to be that g of x that's getting plugged in, so that it goes ahead and follows what we're given. Right? And then if we want to go ahead and look at this function, we have the negative square root of 3 plus 7x. And again, it's usually a good idea to have one function be your inside and one function be the outer version. All right. In this case, I'm going to go ahead and consider this inside piece to be my g of x, because I'm writing it as f of g of x. And then my outer portion to be this negative square root of x. I can also call it negative x to the 1/2 power. It doesn't matter. And this would be my composite function. And now we're going to go ahead and look at the chain rule itself. And the chain rule says I can go ahead, if I have the derivative of a composite function f of g of x, that I can go ahead and take the derivative of f with g of x and then times the derivative of g of x. That probably sounds really confusing, so let's just look at a couple examples here. So basically what we're going to do is we're going to take the derivative of the outside and then multiply it by the derivative of the inside. So if we go ahead and look at this function, y is equal to 8x to the 4th minus 5x squared plus 1, and it's all to the 4th power, what we're going to do is consider our g of x to be the inside, and our f of x to be the outside, which is all this is x to the 4th power. Okay, so f of x is x to the 4th, g of x is 8x to the 4th minus 5x squared plus 1. And then what we're going to go ahead and do is say, okay, so the derivative is the derivative of f. So the derivative of f of x is 4x to the 3rd. And so we're going to go ahead and take our 4x to the 3rd, and then we're going to go ahead and place our g of x inside. And we're going to go ahead and multiply it by the derivative of g of x, which is going to be 32x cubed minus 10x squared, and our 1 goes away. And that is our derivative using the chain rule of this composite function. The same idea goes for this next one here. If we want to go ahead and compute the derivative of 2x cubed plus 9x to the all to the 5th power, again, we want to go ahead and consider our f of x to be x to the 5th, our g of x to be 2x to the 3rd power plus 9x, our inside part. And again, our derivative will be the derivative of f of x. Remember, f of x was x to the 5th. It's going to be 5x to the 4th, and wherever that x is, we're going to replace it with our g of x, which is our inside, and then we're going to multiply it by the derivative of this inside piece, our g of x, which is going to be 6x squared plus 9. I'm sorry, the squared is missing here. It should be 6x squared plus 9. Let's look at an example that might be just a little bit more complicated. Right? So if we want to go ahead and find the derivative of negative 2 times 12x squared minus 5 to the negative 6th power. And again, we want to consider our inside function to be our g of x. So our g of x is going to be 12x squared minus 5. And our f of x is going to be negative 2 times x to the negative 6th power. And when we go ahead and put that all together, we want to go ahead first of all and take the derivative of the outside. So remember, our f of x is negative 2x to the negative 6. And when we go ahead, and the negative exponent and our negative in the front is going to become a positive 12. And then when we subtract 1 from the exponent, it's going to become negative 7. And we go ahead and take our inside function, put it back inside, so our 12x squared minus 5 stays inside. And then our derivative of the inside is going to be 24x. The minus 5 disappears. We want to go ahead and simplify this as best we can. So we're going to go ahead and multiply this 24x times our 12 and get 288x. And then we still have our 12x squared minus 5 all to the negative 7th power. And in order to go ahead and make that a little cleaner, we're going to take all of this as to a negative exponent, because remember, we do not like things still staying to the negative exponent. And we're going to rewrite it as a positive exponent. So we have 288x divided by my 12x squared minus 5 quantity to the positive 7th power once we put it in the denominator. Number 4 here, again, here we go. We want to consider our g of x to be our 3t to the cubed minus 8. And then our outside function is going to be 45x to the 3 over 2 power. And when we go ahead and simplify it, it seems like it's not very simple. So we want to go ahead and take the derivative of our f of x, which is 45x to the 3 over 2. And we end up with 135 divided by 2. And then remember, we got to subtract 1 from 3 over 2, so it becomes 1/2. And we're going to stick our g of x inside as it is, so 3t squared minus 8. And then we're going to multiply it by the derivative of the inside, which is a little bit easier. We got 9t squared, and then our 8 goes away. And then we've got to go ahead and simplify this just a little bit. So we want to go ahead and multiply our 9t squared times our 135 over 2. And then we're going to go ahead, we can either keep the 3t squared minus 8 to the 1/2 power, or we could go ahead and make it a square root. It doesn't matter which way you would like to do that. Our last one we're going to look at, we have negative 5 divided by 2x cubed plus 1 squared. All right. What we want to do is we want to go ahead and rewrite the expression as just an exponent without a fraction. So we're going to go ahead and have our negative 5 minus our 2x cubed plus 1 now to the negative 2 power. And again, we're going to consider our g of x to be our 2x cubed plus 1. And our f of x to be negative 5x to the negative 2. We put that all together. Again, our negative exponent and our negative number become positive. And we got to subtract 1 from our exponent. It becomes negative 3. And our g of x goes on the inside, which is 2x cubed plus 1. And then we're going to multiply it by the derivative of our inside, our g of x, which is going to be 6x squared. And then we're going to go ahead and multiply our 6x squared times 10 and get 60x squared. And again, our leftover piece, 2x cubed plus 1, is to negative 3rd power. Again, we're going to move that negative power into the denominator of a fraction. And we end up with 60x squared divided by 2x cubed plus 1 to the 3rd power, positive as it's in the denominator now. Right, now sometimes we're going to go ahead and have to use both rules. I'm sure you guys have been wondering if that's going to happen. So what I want to do is I want to find the derivative of 3x squared minus x divided by 2x minus 1 to the 5th power. So our f of x in this case would be 3x squared minus x, and our g of x would be 2x minus 1 to the 5th power. So let's go ahead and look at this as the quotient rule. So as the quotient rule, we have the derivative of f of x, which is 6x minus 1, times g of x, 2x minus 1 to the 5th power, and we're going to subtract 3x minus x, right here, our f of x, and our derivative of g of x. And our derivative of g of x is going to be 5 and 2x minus 1 to the 4th power. And then using the chain rule inside of it, we have a minus 2 because we have a function within a function. So for our g of x to take the derivative, we had to go ahead and use the chain rule right here. And then it's going to be over our g of x squared, which will be 2x minus 1 to the 10th. So we had to use, in order to derive g of x, we had to go ahead and use the chain rule. But for the whole function, we're using the quotient rule. Now, we could go ahead and simplify this just a little bit. So we could go ahead, once we go ahead and pull out a 2x minus 1 to the 4th out of both terms, we could go ahead and cancel it with the 2x minus 1 to the 10th, and we could factor out some and cancel, which works out really well for us. And then we're able to simplify this, going ahead and foiling this piece right here, so we get 12x squared minus 6x minus 2x plus 1, and then minus 30x squared plus 10x, And it's going to be all over 2x minus 1 to the 6th because we did some factoring. And then we end up